Okay, we're getting ready to start chapter 3. And in section 3.1, we talk about linear inequalities. And just to give you an idea of what chapter 3 is about, we're going to talk about linear programming. And linear programming has to do with solving systems of inequalities. So basically, you got several different inequalities, and you're trying to find the solution that works for all of them. There's two main ways of finding that. One is by graphing. You've probably done some of this before, so it won't be totally new. In chapter 4, we do an algebraic solution using matrices. That will probably be brand new to everybody. So, okay, let's talk about inequalities. We'll talk about some of the basics first. Basically, the inequality signs: less than, greater than, less than or equal to, and greater than or equal to. So if you have the line underneath it, you've got the equal to. Then you have properties of inequality, and I did this a little different from the book. I just clumped them all together. But you have the addition, subtraction properties, and you got the multiplication, and I could have put division there. But let's just say if you had something where A is less than B, and C is any other number, then basically what you could do, you could add C to both sides. So A plus C, and then B plus C, and the sign stays the same. So if A is less than B, then A plus C is less than B plus C. Or if I did subtraction, A minus C is less than B minus C. And that's exactly the same thing it is as if you had an equation. So now let's go to multiplication. And I should say, and division. I said that a second ago. But let's do the same thing. Let's say I had A less than B, and C is some positive number. Then I can multiply both sides by C. So AC would be less than BC. All I did was take C times each side. Okay, still nothing has changed from what you had when you had equation. Now here's the one you got to worry about. This one right here. On this one, C is negative. So we're going to take A times C. You're going to take B times C, but notice this sign right here started out being negative, and I'm saying being less than, and over here it's greater than. And that'd be the same thing if this is less than or equal to, and you multiply by negative, that would be greater than or equal to. So anytime you multiply or divide by a negative, that's going to flip your sign around. That's a little different than what you've seen before. So make sure you make a note of that. Now, I've got a couple examples here that I thought I'd work through, and then you can see this. And again, this should look pretty simple. So if I wanted to solve this one, it says solve for x, and I've got x plus 4 greater than 3. In your mind, you're going to say, okay, fine, I'm just going to subtract 4 from both sides. So when you do that, essentially on the left, the 4's drop out, and you're going to be x. It's still going to be greater than, and then 3 minus 4 would be negative 1. That's your answer. So the sign did not change. Okay, let's go to this one, and I'm going to move over here. Let me copy it so we got a little more room. 3x plus 2 greater than 5. So what you would do first is probably subtract 2 from both sides, and if you did that, you're going to have negative 3x. Those guys drop out, and over here 5 minus 2 is 3. All I did was subtract the same thing on both sides. But now, to get rid of this negative 3, you're going to divide, so I'm going to divide by a negative number. So the negative 3's drop out, and you got x. Since you divided by a negative, that's going to flip that sign around. That's greater than, so I'm going to turn around. It's pointing the other way. Now it's less than, and then you got negative 1 on the other side. So again, anytime you multiply or divide by a negative, you got to flip the sign around. Okay. Example 3 says, write the inequality in slope-intercept form. So again, all you're going to do, slope-intercept form means you're going to get the y's on the left, or basically just y on the left and everything else on the right. So if I take that 2x and put it over here, that becomes minus 2x. It was positive here, becomes negative there. And I got minus 9. I'm going to do something. This should have been greater than or equal to, and that'll play out more later on. So I'm just going to go ahead and change it now. It was a typo here. So now I want to divide everything by negative 3. So when you divide this by negative 3, the negative 3 drops out and just leaves y. I'm dividing by a negative, so that's going to flip that around. Divide this by negative 3, so that's negative 2 over negative 3 is positive 2 over 3. Negatives dropped out. And then negative 3 goes into negative 9, positive 3. By doing this, now you got it in the form of y less than or equal to, there's mx plus b. M is 2/3, b is 3. And you know we write it that way, so perhaps later on I can graph that if necessary. Okay, page 1 down. Okay, example 4 in the book, I'm not real sure why it's there, but it says write this in vertical form. Vertical form means it's just going to be a line straight up and down. You're going to get an x equals. So I got 1/2 x greater than or equal to 4. So really what I'm going to do, I'm going to multiply both sides by 2. And the 2 here, that leaves just x greater than or equal, and 2 times 4 is 8. And this is vertical form. Now, if I was going to graph that, I'm just going to jump to the side. If we're talking about two-dimensional, I'm going to go over here somewhere. Over here is going to be an 8. You're going to have a straight up and down line. That's where the term vertical comes from. And then greater than means I'm going to shade in everything on that side there. Okay. Example 5. We're given this inequality. We want to know if each of those points work. So I've got y greater than negative 2/3 x plus 4. So my y value is 4. Greater than, all I'm doing is taking that inequality and I'm plugging in my point. So the x value is 3, so it's going to go here, plus 4. And I'll put a question mark in there because I'm wanting to know, is that actually going to be greater than when I get done? So 4, is that greater than? 3's drop out, that's going to be negative 2 plus 4. So is 4 greater than 2? And the answer is yes. We're determining whether that value works. Okay, on B, I got 0, 0, so all I'm going to do, I'm going to put 0 in for y. And I'm going to ask, is that greater than negative 2/3? And for x, I'll put 0 plus 4. You end up with 0 greater than 4, and you're asking yourself, is it greater than? The answer on that one is no. So that means that point does not work for that inequality. All we're doing is just plugging in and seeing if it works. Okay, now, with inequalities, we're talking about two-dimensional inequalities where you got x and y. I want to be able to graph something like this. I got 2x plus 3y greater than or equal to 16. Let me do something here real quick. Okay, similar to what we did before when we were graphing equations, I'm simply going to look at this and say, okay, what's my x-intercept? So if I covered up the y's, I'm going to have 2x equals 16. So my x-intercept is 8. My y-intercept, if I covered up the x's, would be 16 over 3. Okay, so looking at my graph, your x-axis this way, so you got 1, 2, 3, 4, 5, 6. I might have to guess on this one because I've already got this pre-numbered, but there's my 8. If I continue this out here. And then 16 over 3, that's like 5 1/3. So if I went up 1, 2, 3, 4, 5, 5 1/3 is about right there. And we're just going to guess at it. So there's my 2 points. And I'm going to draw my line. And that's exactly the same thing I would do as if it was an equation. Okay, now here's a comment. On this one, I had greater than or equal to. If that would have been just greater than, then this line, instead of drawing a solid line, we would have made a dotted line because that would not have been included. So if there's no line, we're going to make it dotted. I think almost everything you're going to do will have the equals, therefore it'll be solid. But I did want to make that comment in case you saw it. Okay, now that you got the line, that's actually a border. Your answer is either going to be all the points on top or all the points on the bottom. And I don't know. But what I usually do is pick a point, and a really good point here would be 0, 0. So if I plug that in, I said, okay, I got 2 times 0 plus 3 times 0. Is that greater than or equal to 16? All I did is plug zeros in for x and y because that's a good point to put in. I could put any point in, any point that's not on the line. So you're going to have 0 plus 0 is 0. So you ask yourself, is 0 greater than or equal to 16? And the answer is no. That means none of these points down here work. That point didn't work. None of them down here work. Everything up here does. So what you do is you shade this side of it. Now, if I was doing this pencil, I'd probably, shade the whole thing in. Or you can put what they call hash marks. And basically we're saying anything on that side of the line is part of the answer. Or again, you might just shade it in. Now, there's going to be a time in a minute you don't want to shade it in because there's other things that's going to happen. Okay? Or simply your answer is everything on top of the line. And that includes the line itself. Okay? More graphing. Okay, so on this one it says graph 4x minus 2y greater than or equal to 12. So I know my x-intercept is going to be 3, and my y-intercept is going to be, 12 divided by 2 would be negative 6. So do the same thing we did before on the x-axis. Remember, x is this way, y is always up and down. I get a few people who get that backwards. But on the x-axis, we go over to 3. On the y-axis, we go to negative 6. And once you have those 2 points, we're going to draw a line. Make sure your lines are straight. If you turn any type of work into me and they're not straight, I take off for that. Neatness does count. Okay, now we need to decide. Is your answer going to be the points this direction, down and to the right, or up and to the left? Technically, I would say below the line or above the line. Okay, so 0, 0 again is a good point. As long as it's not on the line. 0, 0 is a good point. So if I plug that in, and I take 4 times, I'll put 0 here, minus 2 times 0, is that greater than or equal to 12? So what you really got is 0 greater than or equal to 12. That's no. That means this point does not work. That means everything on this side does. So we shade that all in. And that goes on forever. That's an unbounded region. Okay. Now, I'm going to put my marker away, and I hope this shows up. I'm going to use something I can write with a little bit better. See if I can find something here. I think this shows up. Okay. So now what you've got a system. We want to graph this system here. I've got 2x plus 3y. Sorry, I covered that up. 2x plus 3y greater than or equal to 15. So what I'm going to do, I'm going to say, okay, my x-intercept would be 15 over 2. And my y-intercept is going to be 5. Okay, let's go ahead and graph that. So x is 15 over 2. That's 7.5. So I got 6. Just imagine that going out there. Here's 7. 7 over 2, or 7.5, or 15 over 2 is right there. And then y is 5 is up here. So 2 points determine a line. And I'm going to draw my line. And then I've got to decide above or below. So again, 0, 0 is a good one to put in. So I'll put 0 here and 0 there. So 2 times 0 plus 3 times 0. So that's 0 plus 0. Is 0 greater than or equal to 15? No. 0, 0 did not work. That means none of the ones below work. It means everything up here does. Now I'm going to put the hash marks in here and you'll see why. Because that's just one of my 3 answers. That's just the first inequality. What about the second inequality? Okay, now let's go to that one. So x will be equal to, my x-intercept is going to be 3. My y-intercept is going to be negative 6. X equals 3. And down here is y equals negative 6. So I'm going to graph, or draw my line. Now, if you really wanted to be neat with all of this, I usually make my lines darker. I don't know if that's showing up or not. Where's my other? I think I got too many markers. Some are not working, so I don't know. Let's try this one again. That's better. So there's the first line. Here's the second line. Okay, now we got to decide, are we going to shade above or below? So if I put 0, 0 in, I think you're going to find it does not work. Therefore, I'm going to shade in everything over here. This part is actually the same problem I did up here on top, if you haven't figured that out yet. So the first answer was all of these points up in here, and you can see my hashes. And then my second answer gave me all of these. And so far, see where they cross right in here? They call that cross-hatched. So far, that's my answer. Okay, then the last one says y greater than or equal to 0. Well, if y was equal to 0, it would be all of those going straight across. And since it's greater than, that means my hashes would go up. Now, what's the answer? Well, the answer is where you have crosshatches from all three of your sub-answers coming together. So I already told you after the first two, it was this answer up in here. And the last one said y greater than or equals 0. So that means this becomes an edge. So if you can imagine, we're talking about all the points up in there. Above that one. And basically what I'm doing, I am shading in what they call the border or the individual edges. And then your answer is actually all of that. Okay, and then I put this note right here, vocab, feasible set. That's what they call this. It's the answer to the problem, but they call it the feasible set. And later on, we're going to be doing some work with that, and we'll come up with a feasible set, and then we'll decide what the answer actually is for that problem. Okay, right now the important thing is being able to graph your inequalities and find and be able to shade in that feasible set. Okay, now one more thing to show you here. Okay, so this says feasible set of a system of linear inequalities. Determine whether the points 5, 3, and 4, 2 are in the feasible sets of the inequalities from example 8. So when we go back to example 8, that's what I just did here. We have these three things. I've got 2x plus 3y greater than or equal to 15. I've got 4x minus 2y greater than or equal to 12. And I got y greater than or equal to 0. So what I want to know is these 2 points, and you do it individually. So we'll start with this one. Does 5, 3 work for all three of these? Well, plug it in. If I take 2, I put a 5 here, plus 3 times 3. Is that greater than 15? Put your question mark there. So that's going to be 10 plus 9, that's 19. Is 19 greater than or equal to 15? Yes, that works. But I've got to do it for all of them. So we go here. I'll go out here. 4. I'm going back. I'm putting the 5 in there. Minus 2 times 3. Is that greater than or equal to 15? So you got 20 minus 6. That's 14. Is 14 greater than or equal to 15? No. Okay, and what about this one? Is the y value 3? Is 3 greater than or equal to 0? Yes. So as far as the 0.53, the question says determine whether the 0.53 is in the feasible set. It was here, but it was a no over there. Yes, yes, and no. That means the answer for 5.3 is no. Because it has to be yes on all three of those to make that a yes there. Can't have 2 out of 3. It's got to be all of them. Okay. Now let's go back and try the 4-2. Okay, I'm going to do the whole thing here, and this is going to be for the point 4-2. So I'll start out with the 2x plus 3y greater than or equal to 15. So when I plug in, that's going to be 2 times 4 plus 3 times 2. And I'm asking the question, is that greater than or equal to 15? So you got 8 plus 6 greater than or equal to 15. 14 greater than or equal to 15. That's no. So right away, you know that 4-2 is not going to work. Because remember, it has to hit for all three. Now, just for fun, let's plug in the other one. So 4x minus 2y greater than or equal to 12. So we're going to plug that same point, that 4 comma 2. I'm going to plug that in. So I'm going to have 4 times 4 minus 2, and I'll put 2 into this one. And you're asking yourself, is that greater than or equal to 12? So you got 16 minus 4 greater than or equal to 12. 12 greater than or equal to 12. That's yes. They're actually equal to each other, so that works. And the last one you're going to say is y greater than or equal to 0. The y value here is 2, so what you're really saying is 2 greater than or equal to 0, and that's a yes. So on the 3 of them, you got no, you got yes, you got yes. So the answer to the whole thing is no, because it has to be yes for all 3 of these for that to be a yes down here, to be a part of the feasible set. Okay, so that takes care of this section. We talked about some of the basics. For inequalities, we solved algebraically some easy inequality problems. We did a little bit of the graphing to get a feel for that. I graphed a system, which gave us our feasibility set. And then on the very last thing I did, we took a couple points and decided whether they were part of the feasible set. Okay, next time we'll do more with the systems, and it'll start making a lot more sense of what we're doing. And that leads you to linear programming. Okay, that takes care of this lecture. See you next time.